Okay, so this is how the case statements are used uh, for writing the code in behavioral languages. Okay, and you must have used the begin and end statement also.
Yes, begin. Before, I mean, after always, we should use the begin too, right? No.
Yes, 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 we should use the begin.
Yes. Okay. So that's I use begin case and
Then case,
case.
then alternative, then you again use the begin, then after that it will be end, and then another alternative, then begin the output, then after that it will be going to end. So you can use it. Okay.
Okay. So okay. So maybe I put one place. Yeah. End case. There is no semicolon on end or end case, right?
There is no semicolon and end case and end module. There is no semicolon.
Mm.
But in the case of VSDL, you must be using a semicolon.
Yeah, that's I put it there. End case. I put a semicolon.
Okay, and there is a space also in the case of VSDL. In here, there is no space between end case.
No space.
No
Mm-hmm.
space. So these all things you must remember. Okay. So this is
Okay.
basically I am telling you about the case another statement which we are using multiple times. So using that case statement, you can write down the program of an ALU, arithmetic logical unit of a microprocessor or microcontroller.
Mm-hmm.
So as I told you earlier, also we'll be designing some blocks of the processor as we also learned about the programming.
Mm-hmm.
Okay.
Okay.
So now you can make two modules of a processor. One you can make a ALU. Okay. With
Mm-hmm.
some instructions, for example, let's say 10 instructions. Okay, so now
Mm-hmm.
you can write down okay, so you can write down a ALU with 10 instructions.
Okay.
Okay, uh, sorry, okay,
Yeah.
10 instructions such that
Mm-hmm.
these instructions may be such that uh, add, for example, add instruction,
Mm-hmm.
subtract, okay,
Okay.
uh, ending, ending of two inputs, okay, XORing,
Okay.
ORing, okay,
Mm-hmm.
increment, decrement,
Mm-hmm.
1 2 3 4 5 6 7, multiply, a 1 2 3 4 5 6 7 8, and what else, pass and 0. Okay,
Okay.
so you can design a ALU now which is having these 10 instructions: addition,
Mm-hmm.
subtraction, adding, or increment, decrement, multiply, pass, 0. Pass means you are what you will give, you will design an ALU of 8 bit. Okay, the ALU should be of
Mm-hmm.
8 bit.
Mm-hmm.
Okay,
Okay. Mm-hmm.
so if I draw a block diagram of these things, it will look something like that. This will be
Mm-hmm.
your ALU. Okay,
Okay.
I'm just drawing a, you can say, a chip diagram also. Maybe not
Yeah.
very clear it will be.
Yeah. It's fine. Yes.
Okay, and this
Mm-hmm.
is the output. This will be the control signal. This will be
Okay.
control signal C, as you can see. It is very. This is Y, your output, and this
Okay.
will be your A, another input, and this is your B, and this is your ALU. This is a block diagram of an ALU.
Yeah. Okay.
This is your ALU. You're designing using these 10 instructions. Okay, so now you can design an
Okay.
ALU with these 10 instructions. Your A will be of 8 bit, B will be of 8 bit, and Y will be of 8 bit only. But how much bit you require in order to uh, module
Achieve
all
the
these
10.
10 instructions?
I need 4 bits.
You need 4 bits. So your select line, maybe this will be your select line, or you can say a control signal. This will be of 4 bit. Okay, so this is your select line, this will be of 4 bit, and these all things will be of 8 bit. So you can write down the code for that thing. Okay,
Yes. Yes.
so you can usually use the case statement only.
Mm-hmm. Okay. And what about the pass? That's what I have to do for the pass.
If pass, you can simply you pass the input to the output.
Okay.
You
So
can
just
write
that.
down
Okay. Done.
simple, you can write down for pass you can write down y equals to a. Okay, yeah, or y equals to
Okay.
b. If you're designing pass A or pass B, two instructions, something like that. Okay. For 0, what you will give? You will give y equals to 8 tick b 0. This is for 0. Okay.
Okay.
So this is how you are going to design an ALU. Okay. So you can keep it as an assignment with you. You can note it down. So you have to design an ALU with of 8-bit, having 10 instructions. These are your 10 instructions. Okay.
Okay. Okay. 10 instructions. Just let me write it down.
Okay. So write it down.
And for the 0, I have to compare both of them as a 0, or
No, you don't have to compare. You just have to pass 0 to the output.
okay, okay, okay. So whenever there is a 0, I have to put the output as a 0, 0, 0.
0. For example, the 8-bit 0, so you will put 8 0 on the y. If it is a
Okay.
16-bit, then you will be 16-bit 0. Just you are giving 0 at the output. Okay. And now you can
Okay.
also
Okay.
design a comparator also. If I am talking of a comparator, this is also one of the circuit of your microprocessor. You design comparator of 8-bit, which will have some. What a comparator will do? What it will do? It will just compare two values and give
Mm-hmm.
value 1 or 0. If it is 2, then it will give 1. If it is 0, it will give 0.
0.
Yesterday you have seen all the comparison
Yes.
operators, relation operators, that is equals, not equals, greater than equals, less than
Not
equals,
equal.
and
Yes. Mhm.
other two operators as well. You must be remembering that. So using that 6 operators or 5 operators, you can design a comparator of 8-bit. Okay.
Okay.
Okay. So how much operators are available? That much instructions that you will design. If you are having 5 operators, you will design 5
Okay.
instructions. If you are having 6 operators, you will design 6 instructions.
6. Okay.
Okay, using all these operators. If a equals to b, then y gets the value 1, else y gets the value 0. You know how to use if else statement. I told you right now. You know these all things must be written down inside the behavioral coding only. Okay.
Only.
So,
Okay.
so,
Okay.
so, so you must be using always statements. You must be using if else statements, case statements. So you must be using all these statements. Okay.
Okay. Compare.
So these two basically are, you can say, a module of your 8-bit microprocessor. So you're designing, you have already designed the two components of your processor.
Okay. Okay.
Okay. So let's
Yes.
proceed further.
Okay.
Uh,
Yes.
so apart from the case statements, you can use case x and case z keywords. They will compare x and z all values in your comparison in your alternatives apart from 1 and 0. Okay. With
Okay.
positions, they will also compare x and z. So if you are using case z, it will treat z values in the alternatives, or if you are using case x, it will treat all your x and z values in the alternatives as don't care.
Okay.
Okay.
Mhm.
So, but
Okay.
you remember that it will not be used frequently. Just sometimes you are you see come across these keywords. You must be knowing what they are going to do. Okay. Generally, you don't
Okay.
see the use of these keywords. Okay.